My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. You are welcome to episode number 104 of the 120 Days to Jamb Mathematics with Flash Isaac. In this episode, we shall be looking at integration using partial fraction. Integration by partial fraction. Now, partial fraction is a way of decomposing fractions using polynomials. Remember, I dealt with polynomials where I explained that polynomials are expressions with ascending or descending power of variables. Now, there are two conditions where you integrate using partial fraction. Before I embark on my procedure, it is important for you to know that partial fraction is a major topic in mathematics. However, it is not a part of Jamb mathematics. And integration by partial fraction generally are not questions you should expect when it comes to Jamb. I am doing this, one, for knowledge sake, and two, in case anything changes in Jamb, so you know what to do. And three, for post-UTME. Some schools will set integration by partial fraction in their post-UTME questions. So, this knowledge is not wasted at all. I will scratch the surface of integration by partial fraction. You integrate by partial fraction when one, you have a numerator of the same or higher degree than the denominator. If you have something like this, the numerator and the denominator are of the same degrees. If you have something like this, the numerator is of higher degree than the denominator. So if you are given something like this to integrate, you are therefore absolutely going to use integration by partial fraction. Similarly, when you have linear factors or factorizable expression in the denominator, you integrate using partial fraction. If I give you an expression like this, maybe s at the top or whatever, to integrate, you see that the denominator is factorizable. So here, you use partial fraction. I'll give you two examples. Then if you are interested in integration by partial fraction, go to the mathematics playlist. In the mathematics playlist, I solve everything concerning mathematics, both complex, not complex, and for all levels. But for this Jamb series or Jamb mathematics, I am restricted to the things Jamb expects you to know. Now look at this. This is polynomial of higher degree in the numerator. In this place, you see linear factors in the denominator. If they have given us something like this in the denominator, so long you are able to factorize it to arrive at something like this, then you can integrate using polynomials. For here, it is very, very simple. You factorize the numerator. This is a quadratic expression. And when you are given any quadratic expression, like I've taught you in the previous episodes, you look for two numbers that when you add, you get plus 3. Yes, when you multiply, you get 2, because here is 1. And those two numbers are obviously 2 and 1. Meaning, if you have s squared plus 2s plus 1s plus 2. 2s plus 1s is 3s, and 2s times 1s is 2. So this is very good. Anyway, you are able to factorize the numerator, so long you will get the same answer with me, you are correct. From here you have here and here s in common. So s plus 2 plus here and here they have 1 in common. So 1 s plus 2. This is s plus 2, this is s plus 2. We pick one of them. S plus 2. Then s plus 1 outside. So this is s plus 1. If you feel I am performing magic, please go and watch the quadratic equation video. That will teach you how to factorize. This is the same thing as this. We've been able to factorize this expression. So the integral becomes s plus 2 s plus 1 over s plus 1 ds. Now look at the interesting thing. Here and here are similar. That is the reason we are able to factorize the numerator. So it will cancel with the denominator. This cancels this. So this question is basically integrate s plus 2 ds. And this is integration of sums and difference. Once you integrate s, you are going to get s squared over 2. And when you integrate 2, you are going to get 2s. So this is plus 2s plus c. This is your answer. And if it were a definite integral, let's say 1 here and 0, you simply put s to be 1 first, to have 1 squared over 2 plus 2 times 1. Then minus, you put s as 0 to get 0 over 2, 0 squared over 2 plus 2 times 0. So everything here should give you 0, while everything here should give you 1 over 2 plus 2. So that is your answer if it were a definite integral. Let's look at the next question. Now, anytime you have something like this, the partial fraction takes the form. This is already s over 2 minus s plus 3. So it will take the form a over 2 minus s plus b over s plus 3. This is how it should always be. And if the denominator were not like this, but they have factorizable expression, you factorize the denominator to get something like this and this. After that, write out your normal integral like this, equate it to a over the first denominator plus b over the second denominator. If there were 3 denominator like this, you add plus c over the third denominator. A and b are constant. You will see the reason for this soon. Now, let's find the LCM of here and here. This will simply be 2 minus s plus 3. So a 2 minus s divided by 2 minus s cancels, you are left with s plus 3. Plus s plus 3 cancels s plus 3, you are left with 2 minus s times b. So b minus s, and this is s over s plus 3. Now if you look at this, it shows that s is equals everything here, while everything here is equals everything here. So this and this are the same, while s is equals a s plus 3 plus b 2 minus s. Now we need to look for the value of a and b. How do you look for the value of A and B in this case? You think about your life or you reason, what should I do to make A 0? And what should I do to make B 0? It is very, very easy to figure out this. For example, 0 multiplied by any value, that will give you 0, right? Yes. If that is true, look at this. If here is s plus 3, if you make s minus 3, it means minus 3 plus 3 will be 0. 0 times a will be 0. As such, we've eliminated a. So let's go ahead and try that. Let s equals minus 3. If so, minus 3, this is minus 3, is equals a times minus 3 plus 3. That is a times 0, 0 plus b 2 minus 3. This will give you minus 3 is equals 5b. B is therefore equals minus 3 over 5. Because minus times minus is plus. 2 plus 3 is 5. Now, if we let s equals 2, substituting here, you will have 2 equals 2 plus 3 is 5 times a, that is 5a, plus 2 minus s is 0. B times 0 is 0. The aim is to eliminate b. So we made s 2 so that 2 minus 2 will be 0, and in this other part we will have a meaningful value. From here, a becomes 2 over 5. So b is minus 3 over 5, a is 2 over 5. If we substitute that here, a becomes 2 over 5 and b becomes minus 3 over 5. You therefore find the integral of this part. Integral of 2 over 5, 2 minus s, then the other part minus integral of 3 over 5 s plus 3. Here, multiply both sides by, multiply here by minus, put minus here and minus here, so that this minus and minus cancels. We are doing this so that when you integrate here, you will have 2 over 5 ln 2 minus s. Then here you have 3 over 5 ln s plus 3. So this is your answer. And like I told you earlier, if you have problems or you wish to understand further, you need to know partial fractions, you need to know in and other integrals. Feel free to follow the mathematics playlist itself. You will get all the explanations to these concepts. Ladies and gentlemen, that is it for this episode. See you in the next episode. And don't fail to get the Flashlearners Jamb application. Subscribe to this channel for more amazing videos. And feel free to tell your friends about the Flashlearners